Let's consider this is sun, this is the center of the sun and the earth. So this is one astronomical unit and the length is 1.496 into 10 raised to 11 meter. This is the standard value for the one astronomical unit. The next one is the 1 light year, which is equal to 9.467 into 10 raised to 15 meter. It is already derived by the previous, or I can say the late scientist. So 1 light year, what is the 1 light year? It is the time taken by the light in the 1 year. Means in 1 year how much the light travels. That is a 1 light year, which is equal to 9.467 into 10 raised to 15. We can say in 1 year, if light passing, so in that 1 year it can pass only the 9.467, or we can say the light can only travel 9.467 to 10 raised to meter in 1 year. It is derived by the scientist. So that is the measurement of length, or we can measure the length of a big distance. Here one of the example is how can we measure the large distance. So as I said, if we want to measure the distance between the sun and the earth, it is already measured by the scientists. But if we want to derive, then how can measure it? So there is some method. So that method is or we can say there is a formula which is d theta is equal to ds by r. So r is the distance between the two planets. We can say here the distance between the earth and the sun, and the d theta is the angle, and ds is the distance. Okay, so it is the same as the plane angle formula, right? This one which we have already studied. This same formula we're gonna use here. Okay, so for the larger distance we're gonna use that same formula, which is d theta is equal to ds by r. And if we want to measure the distance between the two things, we can arrange it like r is equal to ds by d theta, this one. So that's how we can conclude, or we can measure the larger distance. Next one is the how can we measure the size of the planet. Same, we're gonna use the same formula, d theta by d theta is equal to ds by r. And here, if this is the sun and this is the earth, okay, and if we want to measure the size of the sun, how can we? So we have a formula like alpha is equal to d by capital D. Small d is the diameter of the sun, and the capital D is the distance between the sun and the earth. As you can understand, this is the same formula which we have used here, which is the angle, the distance, and the surface area of this, or I can say the length of this arc. The same formula we're gonna use here for the measuring of the size of the planet. So here we have considered the earth, and this is the sun. This d is the diameter of the sun, and this capital D is the distance between the sun and the earth. So how we gonna measure the size of the earth? That is the diameter. We already know the formula, alpha is equal to d by capital D, and by the rearranging this formula we can get the diameter of the sun. So we have covered these topics, which is fundamentals, units, derived quantity and its units, supplementary units, and the measurement of the larger distance and the size of the planets. Now we're gonna move to the next page. So we have studied the measurement of the larger distance, but how can we measure the smallest distance or the small distance? So as I said, we can use the scales or any other thing to measure the small distance. But if you want to measure the distance between the electrons, proton, distance between the two atoms, so we can use the electron microscope or the tunneling electron microscope. So this is how we measure the smallest distance between the atoms, any smallest unit which we can't measure by the normal scale. And the next one is the measurement of the mass. How can we measure the mass? So there is a standard value given by the scientists, which is 1 AMU, which is atomic mass unit, which is equal to 1.660540 into 10 raised to minus 27 kg. So we have studied in the fundamental units, the basic unit for the measuring the mass is the kg. Okay, so that's why we are using these units for smallest things. Like if we want to measure the mass of the atom, okay, atomic mass we want to measure. So there is already we are studying that previous study which is done by the scientists already. So there is a standard value for it, which is 1 AMU, which is equal to 1.6605 into 10 raised to minus 27 kg, and which is equal to the 1/12th mass of the unexcited atom of the C12. As we all know, there is a atom and there is a different isotopes for the different atom. So this is the C12 and this value is the 1/12th mass of this C12. The measurement of the time, which is second. This is the smallest unit we can. There is a mini, micro, but this is the standard units which normally used for the measuring the time. So there are the basic formula which we should know, which is density, which is denoted by mu, I think, and which is equal to mass upon volume, and its units is kg per meter raised to 3, which is meter cube. Acceleration, which is equal to velocity upon time, and its unit is meter per second square. Momentum, which is denoted by p, which is equal to mass into velocity. Force, mass into acceleration. Work, force into displacement. Kinetic energy, here you cannot see, but it's kinetic energy, which is equal to half mv square. And the pressure is equal to force upon area, which is equal to kg per meter second square. This is the basic I can say the formula which every physics student should know, which because ये सब हम आगे यूज़ करने वाले हैं in complicated chapters. So this is the first chapter of the standard 11 units of measurement which we have covered, and there are different there are other topics also, but I think these are the important topics which we should know to understand the most complicated chapters which we're gonna study in the future lectures. So this is the basic chapter I can say, or I can say that this is the basic concept which we all should know. So I think that's it from my side. We'll meet in the another lecture. Bye then. Take care. Thank you.